Hello, we are here to help you ace your exams by going over questions with you. The resources we use are written in the description.
Today we're going to do a short review on redox and electrochemistry. As always, please pause the video to read the question and to figure out the answer by yourself before you continue to listen to the solution. Let's start with question 1. In which of the reactions is the underlying substance acting as a reducing agent? First thing that we need to remember is a reducing agent undergoes oxidation. So you want to find which of the underlying substance undergoes oxidation. In order to do that, we can take a look at the oxidation number. So let's start with A. The oxidation number of any element is 0. And the oxidation number of chloride on the other side of the equation is -1. -1 comes from the fact that chloride ion has a -1 charge. So therefore, chlorine gains electron in this case, becoming more negative, and gain electron is reduction. Chlorine is reduced. It is not oxidized. Second option, let's take a look at magnesium oxide. Magnesium in this case is not an element, it is a part of a compound. So magnesium oxidation number is +2, whereas oxygen or oxide in this case is -2. Magnesium on the other side is still +2, and oxygen on the other side is still -2. So in this case, reaction B is not a redox reaction. There is no change in the oxidation number of these substances. Equation C. Oxidation number of H is 0. Actually, we don't need to do hydrogen because the underlying substance is copper oxide. So oxide is -2, therefore copper is +2. And on the other side, copper becomes an element. Element oxidation number is always 0. Now O still retains its -2 oxidation number. So in this case, copper in copper oxide gain 2 electron to become copper element. Gain electron is reduction. Let's see if carbon monoxide is in fact oxidized. Now there are two ways in this case. Oxygen, as always, is -2, therefore carbon is +2, and oxygen again -2, and carbon is +4, because there are two oxygens, and each oxygen has a oxidation state of -2, so two of them make -4. You want to balance, you want to cancel this -4, so you need a +4. Okay, so in this case, because the oxidation number of carbon increase, therefore we know carbon monoxide undergoes oxidation. Increase in oxidation number means oxidation. There is another way to explain this. Carbon monoxide has one oxygen, but carbon dioxide has two oxygen. Therefore, you can also say that carbon monoxide gains an oxygen. Now, gain an oxygen is oxidation. So, carbon monoxide is indeed a reducing agent because it is oxidized. Question 2. Disproportionation reaction is where the same element is both oxidized and reduced. Take a look at reaction A. Let's again use the oxidation number. Chlorine oxidation number is 0 since it's an element, and chloride and hydrogen chloride is -1 because hydrogen is +1. Now let's take a look at this other compound. Hydrogen is +1, oxide is -2. That makes chlorine in the middle there +1 because you want a total of 0. Okay, so this total here is 0. You want a total of 0 because this compound has no charge. Okay, that means the charge is 0. Okay, so let's assign the oxidation happens here. This is where chlorine increase in oxidation state, and reduction happens here, a decrease in oxidation state. So this is a disproportionation reaction. The second reaction, lead +2, O is always -2, and N in the middle there is +5. Let me just review quickly how I get +5. So Pb NO3 2 is composed of two ions, lead 2 plus and O3 minus. Okay, two types of ions. Now NO3 minus, okay, the oxidation number of O is -2, and you have 3 of them, so total -6. On the right is -6. On the left must be how many to get a total of -1? I get -1 from this charge, okay? Because this is an ion. An ion has a charge. So that charge is the total oxidation number. Well, -6 plus 5 gives you -1. So that's how I get oxidation number of -5 for nitrogen. Back to equation B. So lead here is still +2, no change. Nitrogen is +4 and oxygen is 0. So let's do the assignment here. Nitrogen is reduced. What's being oxidized? O is oxidized. Now, is that the same element? That's not the same element. It's nitrogen reduced, oxygen oxidized. So not the same element. It's not a disproportionation reaction. Next, copper oxidation state is 0. Now, since sulfate stays sulfate, that means the oxidation number of S and O don't change. But here we have another compound, another sulfur compound. So we're going to assign this the sulfur oxidation state. Okay, hydrogen is +1, oxygen is -2, right? There, that makes. Let me just do the math here. That makes a -8 in total, +2 in total from the hydrogen, and therefore S must be +6 because you need a total of 0. Okay, so S is +6. Now copper is +2, and here sulfur is +4. So copper metal undergoes oxidation and sulfur here undergoes reduction. And it's not a disproportionation reaction. The last one, copper again 0, oxygen here -2, hydrogen +1, nitrogen +5. If you do the math, copper here is +2. Let's leave nitrate alone. You don't need to assign the oxidation number because it's exactly the same as the nitrate on the left hand side. Okay. And on this side, we have another nitrogen compound, so that's -2, and nitrogen in this case is +4. So copper is oxidized and nitrogen in the nitric acid is reduced. Again, copper and nitrogen, they are not the same element, therefore this is not a disproportionation reaction. So the answer is A, as we found out earlier. Acidified potassium manganate is a very strong oxidizing agent. And the color is purple. Now, when this oxidizing agent is reduced, as we learned earlier, that oxidizing agents are the substances that gets reduced. Okay. The oxidation state of manganese decrease from +7 to +2. Okay, so manganese MnO4 minus, okay, it will be reduced to Mn2 plus. The color here turns from purple to colorless. Why does the color change? Because the oxidation number changes. Manganese in manganate 7 is a +7 oxidation state, whereas manganese 2 is a +2 oxidation state. Okay, so let's take a look at the question. When you react acidified potassium manganate, which is a strong oxidizing agent, with ethanol, ethanol gets oxidized to ethanoic acid. So that is CH3CH2OH gets oxidized to give you CH3COOH, okay, and plus water. 2 oxygen here, and the reaction is balanced. Okay, so which of the following conclusion about ethanol is observed? Ethanol is oxidized, therefore it is a reducing agent. It's correct because it reduces the oxidation state of manganese. That is correct. Is it an alkali? It's not an alkali, and being alkaline or acidic does not have anything to do with the final color. It's an oxidizing agent. It is not an oxidizing agent because ethanol is not reduced. Ethanol is oxidized. The last option is neutralized by potassium manganate 7. Now this reaction is not between alkaline and acid reaction, but it's redox reaction. So it's not a neutralization reaction. Answer is A. Question 4. Rusting of iron requires the right conditions, and the right conditions are the presence of oxygen and water. So A and B, these conditions are without water. So A and B cannot, rusting will not work, will not happen. Okay, and C and D, you have oxygen, you have water, and you have iron. So let's take a look down here. You have to think of the reactivity of these two metals. Iron and copper. Iron is more reactive. More reactive. Okay. Therefore, iron will be the one undergoing oxidation. So in this case, iron is oxidized to iron 3 plus in a rusting reaction. So this whole setup, C and D, this is similar to electrolysis. Okay, oxygen in water acts as the electrolyte. This acts as the electrolyte. And copper and iron act as the electrodes. Okay. So the one that is more reactive is the one that undergoes oxidation. So in this case, in the setup C, copper cannot protect iron from getting oxidized because copper is less reactive. However, in setup D, magnesium is more reactive. And what happens? Magnesium undergoes oxidation. In this case, it becomes magnesium ion, which is Mg2 plus, and releases 2 electrons. Okay. So it's not the iron that undergoes oxidation, but it's the magnesium because it's more reactive. So answer is D. Next question is a structured question. Remember to pause the video anytime you need to read the question. You need to balance the equation by inserting numbers on the dotted line provided. So let's take a look at iodine. On the right hand side you have 2 iodine, on the left you have only 1 iodide, so you need to multiply that by 2. On the left hand side you have 2 oxygen, on the right you have 1 oxygen, so you need to multiply that by 2 to make sure that the number of oxygen is the same before and after reaction. So now on the right hand side you have 4 hydrogen, and on the left hand side you have 2 hydrogen here and 1 hydrogen there. So you can multiply that 1 hydrogen by 2. Why not multiply the hydrogen on hydrogen peroxide? Because that's going to mess up the number of oxygen that we have, which is already balanced before. Okay, so let's do a final check. We have 2I here, 2I there. We have 4 hydrogen here, and we also have 4 hydrogen there, and we also have 2O and 2O here. Okay, and this is just 1. If we do not write the number, it means just 1, but because there is dotted line, write the number down. Now, other than that, we have to also check that we have also balanced the charge. So on the left hand side here, we have 2 minus, this one we have 2 plus, and this is 0. That means a total of 0 charge. On the right hand side, we have 0 and 0, also 0 total charge. Now the equation is completely balanced. Identify the oxidizing agent. Again, oxidizing agent is the chemical that gets reduced. So, gets reduced. Let's take a look at our equation once again, and let me just delete this. Right, assign the oxidation state. Iodide oxidation state is -1, iodine is 0. Hydrogen +1, hydrogen here +1. Now, oxygen is usually -2, but in the case of peroxide, oxygen oxidation state is -1. In water, hydrogen +1 and oxygen is again -2. So let's take a look which one undergoes oxidation and which one undergoes reduction. Iodide becomes iodine. It has to release an electron, and it also the oxidation state rises. That means it's oxidation. This is oxidation reaction. Oxygen in hydrogen peroxide has an oxidation state of -1, and in water it has an oxidation state of -2. So that's a drop, a decrease in oxidation state, and that is a reduction reaction. So what gets reduced is hydrogen peroxide. Your explanation using oxidation state is that the oxygen oxidation number of oxygen decreases from -1 to -2. Or in another words, H2O2 is reduced. Okay. What color change will be seen when this reaction is carried out? So iodide is colorless. Potassium iodide, sodium iodide, okay, they are colorless, and this acid is also colorless. Hydrogen peroxide is also a colorless solution. However, iodine, and you guys should know this, iodine is brown in color. So what color change would be colorless to brown? Okay, question 2 of the structured questions. Molten lead 2 bromide was electrolyzed using carbon electrodes. Now, carbon electrodes are special, just like platinum, they are inert electrodes, so you don't need to worry about them reacting, okay? They are not undergoing any reaction. Write the ionic equation for the reaction at the cathode. Cathode is where reduction happens. So again, as I mentioned before, this is how I remember it. It's consonant and consonant together, cathode reduction, whereas anode oxidation. Okay, anode is where the oxidation happens. It's vowel and vowel. So what's being reduced? Because cathode is negatively charged, it is called cathode because it um, attract cation. Okay, so if we have molten lead 2 bromide, our cation is lead 2. Cation means positive ion, and it is attracted to negative electrode. So lead 2, which is in this case liquid, right? It's molten. It will undergo reduction to become lead um, metal. Okay. So where do we put the electrons? Remember, when we balance equations like this, be it half equation or full equation, we always have to balance the number of atoms and also the charge. Okay. So on the left hand side we have one lead, and on the right we also have one lead. That's balanced in terms of the number of atoms. However, we see that on the left we have a +2 charge. On the right we have 0 charge. So the charge is not balanced. Where do we put electrons to balance them? We only can put electrons to balance the equation. So we put the electrons on the more positive side so that it will now become a total of 0 charge. Okay. So plus 2 and minus 2, that gives you a total of 0. And now the reaction equation is balanced. So you can pause the video to try, do A2, and when you finish, you can continue watching. For 2A2, anode attracts anion, the negative ion. So in this case, our negative ion is bromide, and that's going to be converted to bromine. Okay, now bromine in this such high temperature, it will be a gas. Now let's balance the equation. There are 2 bromines on the right, so you need to multiply the bromide on the left and make it 2. Now total charge on the left is minus 2, total charge on the right is 0. So where do you put the electrons? You put the electrons on the side where it's more positive to make it the same as the other side. So in this case, you put it on the right hand side, 2 electrons, and that gives you a minus 2 total charge on both sides. And if you think about it, reduction and oxidation, they must have electrons on opposite side. Okay, gain electron is reduction, lose electron is oxidation. That's why the electrons must be on opposite sides. If your answer have both electrons on the left hand side or both on the right hand side, then you have to recheck your answer. Right, state the observation at the cathode. Observation at the cathode during electrolysis. So on the cathode, what is being produced? Lead is being produced. So you would see lead, but what do you see? If you just write down lead is produced, that is not an observation. Observation is what you can see. How do you know it's lead? So you just say a silver deposit. Why silver deposit? Because the color of most metals is silver, gray silver color is produced on the cathode. And that silver deposit is lead. It's actually not silver like as in Ag, but it's silver, that's a silver colored deposit. Okay. Now this question. In this question, we are no longer electrolyzing molten substances, but it is a solution. Now, in solution, we have water. Solution is anything that is dissolved in water. So, what happens here? First, we have to know what ions are in concentrated sodium chloride. What ions? Sodium chloride ion. And then you have water, so that gives you H plus and OH minus, right? Between sodium and hydrogen ions, the one that gives you a less reactive product is the one that's going to be reduced. So if sodium was reduced, it would give you sodium metal. If hydrogen was reduced, it's gonna give you hydrogen gas. Okay, so which one out of the two products, sodium or hydrogen, is less reactive or more stable? Is the hydrogen. So in this case, hydrogen is formed and sodium ion stays as ion. Okay, so um, let's balance this equation. On the right, we have 2 hydrogen from hydrogen gas. On the left, we also need 2 hydrogen. And where do we put the electrons? We put the electrons on the left-hand side, 2 electrons. So now we have a total of 0 charge on the left and 0 charge on the right. Charges are balanced. Okay, now between chloride and hydroxide, which one is going to be oxidized? Now we see that this electrolyte is a concentrated solution. Concentrated solution means you have dissolved a lot of sodium chloride into a little amount of water. Okay, so there is more chance for chloride now to be reacting to get in touch with the anode. So in concentrated solution, the halide, is it whether it's fluoride, chloride, bromide, or iodide, are going to be oxidized. But in dilute solution, hydroxide, which is from water, is going to be oxidized. Okay. So concentrated, you go for the halide. So our halide is chloride. It's gonna produce chlorine. So let's again balance the equation. 2 chlorine and 2 chlorine. And I need 2 electrons on the right to balance the charge. Now, describe the observations at the electrodes of P and Q. So on P, what are we producing? P is the positive electrode and Q is the negative electrode. How do I tell? I tell by the length of this line that indicates battery or power. Okay, if the line is longer, it's a positive terminal and negative terminal is represented by the shorter line. So electrode P is the positive electrode and that means it's the anode. And electrode Q is the cathode. Okay. Positive electrode attracts negative ion. So anode attracts chloride. And what happens? Chlorine is produced. How do you know it's chlorine? What color is chlorine? Pale green or pale yellow-green gas is produced. And on Q, Q is the negative electrode. It attracts positive ion and hydrogen is produced on Q. So Hydrogen is a colorless gas, so just say colorless gas is produced. Okay. And look at what happens here too. Concentrated sodium chloride solution with universal indicator. Okay, what does this mean? Universal indicator is added to monitor the change of pH. So as hydrogen ion gets reduced, you have less and less hydrogen ion. So now the concentration of hydroxide ion is larger than the concentration of hydrogen ion. Okay, so the concentration of OH minus is now larger, higher than the concentration of hydrogen ion because hydrogen ion has been reduced. Okay, so the solution is getting more and more alkaline. All right, so how does the pH of the electrolyte change? The pH increases, and it's because hydrogen ion is reduced to hydrogen gas. So the concentration of hydroxide ion is now larger than the concentration of hydrogen ion. Last question. Suggest why iron is not suitable to be used as an electrode. Now, what type of metal is iron in terms of its reactivity? Iron is moderately reactive. So iron could react with the chlorine that is produced on the anode. So this is a potential reaction that could happen because iron is a moderately reactive metal. That's all for today. Thank you.
You did great! Leave a message if you have further questions or suggestions. Please like, subscribe, and share if this video has been useful to you. Thank you!